This problem is from the MIT integration bee, and it's like a total jump scare. Most students see this wall of integrals and immediately think they're out of their league. But the truth is, this is actually an entry-level problem. You just need some basic calculus. If you know that the integral of x is x squared of 2, x squared divided by 2, you have everything you need to solve this problem. So, each of these S marks you see here is the same operator. We can use this fundamental theorem of calculus to solve it. We can say the integral from a to b of x dx is equal to 1/2 times b squared minus a squared. Because the integral of x dx, the indefinite integral, is just x squared divided by 2. So, we started at the far right with our c value and passed the result to the left. The result of one integral becomes the stop or start point for the next one. We can look at the far right. That's our starting block. So, we can call this value as k. The integral from 0 to 1 of x dx will then equal to 1 squared minus 0 squared divided by 2, which is 1/2. If we call this value as k, this k is being fed into two different paths, the upper path and the lower path. Step 2 is the upper path, which is the ceiling. The top branch is easy because its bottom number is always 0. We can just square the previous result and divide by 2. We can take our seed, 1/2. Well, 1/2 squared is equal to 1/4. Divided by 2. Is equal to 1/8. And then we can take that 1/8, square it 1/64 divided by 2, that's 1/28. So we can say that the upper ceiling, or stop point, is 1/128. That's one of the key numbers here. And then step 3 is the lower path, the floor. The bottom path is where people trip up because the bottom number is 1. This will introduce a negative number. Take our seed, 1/2, square 1/4, now we subtract 1 because the lower limit is 1. And then we're going to keep this number in mind, 1/128. And then we have 1/4 minus 1 equals to 3/4. And do not forget a negative sign. So, we're going to divide by 2 to get negative 3/8. Divided by 2. And then we can take that negative 3/8 and square it to get negative 3/8 and negative 3/8, which is 9/64. So then we can subtract 1 again. Negative 3/8 squared 9/64 minus 1 would equal to negative 55/64. Divide by 2 to get negative 55 divided by 128. And then, after we get negative 55 divided by 128, the final step is the big integral on the left. We have 1/128 as the ceiling, negative 55/128 as the floor of x dx. And then we can simplify this. Equals to 1/2 of 1/128 squared minus negative 55/128 squared. And we don't need to square 55. Use the difference of squares. A squared minus b squared equals to a minus b times a plus b. So then we'll have this will equal to, after simplifying the fractions, we'll have negative 189 over 2048. There's some slight calculation here, but then you'll see that it looks complex, but with some basic logic and a bit of arithmetic cleverness, we can crush an MIT integration problem. So if you found this breakdown helpful, drop a like and subscribe. I'll see you in the next one.